First and foremost, it's important that you have a lot of fun as you learn to code. If you're having fun, you'll be enthusiastic and that will allow you to be more creative. But there's some things that can get in the way of having fun. So it helps to understand that you're on a learning curve. There will be some things that you need to know before you can move on to more complicated projects. So even though you may have some ideas of what you want to do with your new skills, you might find that you don't quite have all of the pieces that you need yet to accomplish it. If that gets frustrating, just set your project to the side and play with what you do know. Playing is really important in discovering what kind of flexibility you have in the code, and in getting that boost that comes with building things that actually work. Keep in mind that even when you're doing something that doesn't seem very practical, there will always be a practical application to what you're learning in the process. For instance, in this series, we have a couple of rather whimsical examples that we build up over time. In one, we build a Mad Lib-style random replacement generator, and in the other, we build a text adventure game. These don't seem super practical at first, but they're entertaining, and that makes it easy to think of things to do with them to add additional entertainment value and help work on the tools that you have. And eventually, you'll see that the examples do have real-world applications. To get the most out of the code examples, consider typing out the code instead of copying and pasting. This will help you identify points where you don't fully understand the code, and it will help build memory for common patterns that will allow you to eventually write code from scratch. You can also start trying to remember larger and larger chunks of code to type out without looking back at the example. For instance, start by looking at a single line and then type it out completely without looking back at the code, and then try several lines at once. Eventually, you'll be able to understand the full logic of the code and then can recreate it from scratch without looking at the example at all. As the series progresses, the examples will get more complex. Understand that when we built these examples, it took us a while to get the code right. We ran into errors, there were logical flaws, and situations we didn't anticipate. So as you start to produce your own code, realize that it rarely ever works the first time around, or even the second time, and that's okay. Creating code feels a bit like scrambling, and it's common not to realize exactly what you're trying to accomplish until you're nearly all of the way done. So while there will be a lot of errors along the way, and there will be times when you feel a little lost, even in your own code, this is normal, and the way out of it is to just keep plugging away. We'll also walk you through some techniques on how to ground yourself when you're dealing with complicated logic in code. If you're new to programming, it's easy to feel overwhelmed when you look at code, and that's also normal. What's happening is that you're looking at a totally new language, and it doesn't make any sense just yet. But the basic idea behind programming is pretty straightforward, and that can give you something to hang your hat on while you're learning the language. So here it is. Programming is a combination of three things: data, logic, and operations. Most of the time, the goal of programming is to automate tasks that might be error-prone, time-consuming, or plain boring to do manually. Data is any kind of information that can be captured digitally. This could be a list of names, a set of addresses, or digital photos, among other things. And logic is just the process of reasoning. In our daily lives, we use logic all the time. If you think of calling a customer support line, they'll ask you a series of questions, you'll answer them, and then they'll ask you another series of questions based on your answers. What they're trying to do is get to the bottom of a problem by using logic. And you can often automate processes like this by creating a program that captures our logic, making it possible, in the case of a support line for example, to serve an unlimited number of customers at the same time, instead of being limited by human staff. That's pretty powerful, and that's just one example. So part of a programming language includes structures that represent this logic. The other part performs operations, which is something that changes data in some way. So for example, if we have a list of addresses, we can use an operation to sort them alphabetically, or use an operation to change the size of an image. And that's it. Everything you see from here on out fits one of those three categories: data, logic, and operations. On top of that is simply a set of conventions and patterns that you'll start to recognize more and more of as you work through the series. For most of us to start getting creative with code, we need to see a set of patterns first. Just like when you're learning a language, you need to hear words, and then you need to hear sentences that use those words, and then conversations that use those sentences. Patterns that you see in code are like a phrase in spoken language, and you can often use the same pattern in multiple contexts. In the first part of this series, we introduce you to the fundamentals, the words and the structure that makes up the language, and then the second part, we focus on integrating different patterns into our code.